Hello friends, welcome to the after class lessons. This channel is intended to serve as a refresher. If you're new here, please support us by subscribing so you can get a notification whenever a new video is posted. You are also welcomed to like the videos you find helpful and also do leave a comment telling us what you thought and what should be improved to better serve you. Now, in this video, I will be going over 3 examples of the first order linear differential equations. That said, let's get started. So, in this example, I'm going to show you how to solve a first order linear differential equation with a given initial condition. The problem that you are given is this right here, 4 times y prime plus 8y equals 0. And you're also given the initial condition such that y of 0 equals 2. Now, before we solve this problem, there are 3 things that I want you to keep in mind, and it is always best to look out for these things before you solve any differential equation problem. The first thing that I want you to take note of is that this problem here is of a first degree. It is a first order, okay? And you know that this is a first order by looking at this first term here. You are given 4 times y prime. That implies that this is a first order. Now, in any case, should this have been 4 times y double prime, then that would have implied that this is a second order differential equation. And it would have been the same for the third, fourth, fifth order, and so on. The next thing that I want you to realize is that in this problem, you do not have any mixed variables. You are only dealing with y's. Okay? The third thing that I want you to notice, which we already made note of, is the fact that you are given an initial condition. Moving on, before you solve this problem, it's probably best to keep in mind that the solution to the first order linear differential equation will always have the form y equals capital C times e raised to s times t, where capital C is the constant and s equals real roots or real zeros. Now, because in this equation there are no mixed variables, so we can just dive into the problem and start solving it. The first thing that we would have to do is rewrite this equation in the standard polynomial form. When I do so, I get 4 times s plus 8 equals 0. Now, before I go any further, you are probably wondering, where did the s come from? Well, the s came from the solution form that I gave you up here. I need to be able to solve for this s up here. That is why I'm using the variable s in this equation. So now, the next thing that I would do is try to simplify this equation best as I can. When I do so, I would divide by 4, and that would leave me with s plus 2 equals 0. After that, I would have to solve for s. When I do so, I move the 2 to the other side of the equal sign, I get that s equals negative 2. Now I have a value of s, so I can just take that value of s and replace it up here with a negative 2 times t. Okay? And when I do so, this is what I get. I get y equals c times e raised to negative 2t. Do keep in mind that this is just a partial solution. It's not the complete solution. Why am I saying that this is a partial solution? I am saying so because we still need to solve for the value of c. In order to solve for the value of c, we have to come back to the main problem and look at the initial conditions that we were given. What this initial condition is telling me is that in this partial solution, wherever I see t, I'm going to replace it with a 0. And wherever I see y, I'm going to replace it with 2. If I do so, this is what I get right here. 2 equals capital C times e raised to negative 2 times 0. Do keep in mind that e raised to 0 is just a 1. So if I take the 1 and I replace it with e raised to negative 2 times 0, I would end up with c times 1 equals 2. So that would imply that c equals 2. Now I have found what the value of c is. So I would take the value of c and replace it here and put it here. in the partial solution. When I do so, I get the full solution. I get y equals 2 times e raised to the negative 2t. This here is the solution to your given first order linear differential equation. Now, that's about it for this first example. It's a much easier one because you did not have any mixed variables, so that was the direct. You didn't have to do any variable separations. And next, we are going to move into the second example, which contains mixed variables. All right, and if you do have any questions on this problem, maybe something I didn't explain or forgot, do leave me a comment and I'll be sure to get back to you. Okay, thank you. Moving on to example 2. Okay, guys, moving on with the second example. This example is slightly different from the first example. And before we solve this problem, the first thing that we are going to do is go through the checklist. Now, here you are given y prime plus 2 times x squared times y equals x squared. Let's do the first check. This here is still a first order linear differential equation, because by looking at the first term, it is only y prime. Okay, keep that in mind. And then now, different from the first example, this one now contains mixed variables. You have x's and you have y's. Okay. The third thing is that in this equation, you are not given initial conditions. So we won't be using the general solution form of the first order linear differential equation, which we said was y equals capital C times e raised to s times t. We're not using that. Okay, so the first thing that we're going to do with this problem, because it contains mixed variables, is that we are going to do what is known as variable separation. Okay, what does that mean? All that it means is that we need to separate the x's from the y's. We need to have our y's on one side and the x's on the other side. Now, to do so, I'm going to start by moving this middle term right here, the 2 times x squared times y, to the other side. Now, when I do so, I get y prime equals x squared minus 2 times x squared. When I do that, now I am able to separate the variables. So what I have to do is I have to factor out the x squared from this equation. When I do that, I get y prime equals x prime times open parentheses 1 minus 2 times y closed parentheses. Then I can divide both sides by 1 minus 2y. When I do that, I would get dy divided by 1 minus 2 times y equals x squared times dx. Now, what this here tells me is that now I have to take the integral of each side respectively, okay, or with the variable. So on the left hand side, I have variable y, and on the right hand side, I have variable x. So on the left hand side, I'm going to take this integral with respect to y, and I'm going on the right hand side, I'm going to take the integral with respect to x. Now, to do this, for me myself, I'm going to use the substitution, the u substitution. So I'm going to say let u equals 1 minus 2 times y. Then I will take the derivative, and the derivative becomes, well, I find that dy would equal negative du divided by 2. Okay. Then I would take the integral of the 1 over u, because remember this bottom part here is now what I call the u. So now I'm going to have 1/2 negative 1/2 times the integral of 1 over u times du. do remember that the integral of 1 over u, that is equal ln of u, okay? And then I can take, and then do remember that I'm multiplying that ln of u with negative a half. That's what I did here. And then of course I replace the u with what it should be. It should be 1 minus 2y. That is the solution of the right hand side. It's going to be negative a half times ln of 1 minus 2y. Then moving on to the right hand side, which is a little bit easier, if you take the integral of x squared dx, you would get 1/3 times x cubed. That is the solution. I'm going to take those two solutions and I'm going to set them equal each other, because do remember the y represents the right hand side and the x's were the right hand side. So the y's were the left hand side and the x was the right hand side. So I'm going to set those two equal each other. And now the next thing that I'm going to do is, because this is still not quite the solution, okay? It's not quite the solution because I need to solve for y. What is y? That's what the problem is asking you. Solve for y. In order for me to solve for y, I'm going to take, I'm going to raise all of this to the, I'm going to do e raised to negative 1/2 times ln of 1 minus 2y equals e raised to 1/3 x cubed. Now, when I do e raised to ln, that they just cancel each other. It's a reduction. They just cancel each other. So I would just end up with 1 minus 2y, okay? Which would equal e raised to negative 2 over 3 times x cubed. You're probably wondering, where did the half go? This 1/2, negative 1/2. Well, it came down also, but I multiplied it through. Okay, I multiplied it through on each side, and then I ended up with this right here: 1 minus 2y equals e raised to the power 2. That's because you see, like on this side, you only had e raised to 1/3 times x cubed. But when I multiplied that 1/2 that came down, it became e raised to negative 2 over 3 x cubed. Okay? Then I'm going to take this one and move it to the other side of the equation so that I end up with negative 2y equals e raised to negative 2 over 3 times x cubed minus 1. And therefore, I would be able to solve for y. To solve for y, all I have to do is divide through by negative 2. Now, when I divide all of this by negative 2, I would get y equals 1/2 times 1 minus e raised to 2 over 3 times x cubed. Or you can just leave your answer as I have it over here. Okay? And so now this here becomes the solution to your mixed variable first order linear differential equation. Do notice that I told you, like, the solution of the first order linear differential equation is y equals capital C times e raised to s times t. Well, guess what? That is here. It's right here. You see it? It's right on top. And the c in this case is just 1. The value of c is 1. Okay? And that's how you solve the mixed variable differential equations. If you have any questions on this problem also, just like the first one, please do leave a comment and I will get back to you. Maybe there's something that I did not explain or something that did not make sense to you. I would be happy to clarify that. All right, let's move on to the third and final example. Okay. Okay, guys. In this third example, we are given another mixed variable first order linear differential equation. If we do our check, this is indeed a first order linear differential equation because you can see here you are only given 4 times y prime. Okay, so it's a first order. You can see that there are mixed variables. You have y's and you have x's. Okay, and then of course by noticing you are not given any initial conditions. So much like the second example, the first thing that we will have to do is do what is called variable separation. And actually, before we even do the variable separation, the best thing that you would have to do probably to keep things much easier is divide through by 4, simplify this equation, and then we can do variable separation. Okay, so this is what you're given over here. You have y, you have 4 times y prime equals 16y plus 4x. Then I'm going to do what? I'm going to divide through by 4. If I divide through by 4, I would get y minus 4y equals x. This here, the y minus 4y equals x, comes after I have done what? After I have done variable separations. Because now you can see you have y's on one side and you have x's on the other side. Also, do notice that once I have done so, there's not much else I can do to this problem as it is. I cannot separate y primes from just the y. Okay, so that means that this equation I need to present it in a standard form, which is given here. And I'm sure this here will be given to you in your cheat sheets, or maybe you just have to remember it. So the standard form states that y prime plus p of x times y equals q of x. Okay, and then the next thing that we're going to do is we're going to use what is known as the integrating factor. That also you would have to remember or put it down in your cheat sheet. And the integrating factor states is simply e raised to the integral of p of x times dx. Okay, so p of x is this middle term right here. Now, if I take this, if I put this into form, the the e raised to the integral of p of x dx, I would get e raised to the integral of negative 4 dx. I'm taking this 4 right here. Okay, this negative 4 is what I'm putting in here for p of x. And then if I integrate this e raised to the integral of negative 4x dx, I get e raised to negative 4x. That's the So now this here, the e raised to negative 4x becomes your integrating factor. Once I get the integrating factor, I am going to multiply the both sides of that equation with the integrating factor, which is what I have done here. As you can see, I have e raised to negative 4x multiplied by parentheses, open parentheses, y prime minus 4y close parentheses equals x times e raised to negative 4x. That is just this right here. Okay, I'm multiplying both sides of this equation with the integrating factor. Okay. Now, after I do so, the left-hand side I get dx times e raised to minus 4 times x, the whole thing multiplied by y. Okay? And now, if I integrate that, I would have, notice that now in this equation I have the integral of d of x, d over dx, okay, multiplied by e raised to negative 4x times y equals the integral of x multiplied by e to the minus 4x dx. Okay, Now it's now since I'm taking the integral of the left hand side, that's what I'm doing here. This integral, if you refer to the table of integration, this one is one of those special cases. It's one of those special integrals where you are given the solution to be this. Okay, the general solution of this form of integral is going to be x over a minus 1 over a squared, all multiplied by e raised to a x plus c, a constant since it is an indefinite integral. Now, the next thing that I would do is now I'm going to look at the right hand side of the integral of this equation right here. Notice that in this equation, sorry, notice that in this left hand side I have an integral, and also I have a derivative. An integral times a derivative, they just cancel each other out. Okay, so that leaves you with just this right here. It leaves you, so the derivatives are gone and the integral is gone, so you're only left with e raised to negative 4x times y. That is what you see here. Okay, and then this solution to the right hand side, I'm just going to write things. What I did was, since I actually, I didn't solve for this, I just took it from the table of integrals that it is, and I just filled it up. I filled in those variables because I know my a's is the 4, okay? And then, yeah, the a is the 4 really, but x is x, and everything else just remains the same. And that's what I got here, okay? And now you would have uh, this here is what you have left once you do that. And remember, because you are solving for y, you have to divide both sides of this equation with the integrating factor, which is e raised to minus 4x. If I do so, I would get y equals negative x over 4 minus 1/16 plus c divided by e to the negative 4x. Okay, or if you want to, you can leave your answer in this form right here. The only difference is that I moved this whole term, the integrating factor, under the constant c. I multiplied it, and that changes the negative 4x into a positive 4x, and that's all there is to it. Okay, and so with that, we have solved one example of a first order linear differential equation without any mixed variables. We saw how to go about those type of problems, and we've also solved two mixed variable first order linear differential equations, and in each we learned something new. In the one that we couldn't really separate any further or factor out anything, we ended up using the standard form, and also we introduced the integrating factor. Okay, and that's what we're going to use. Those are the only two new things that we learned in the third example. And that brings us to a conclusion of this of the first order linear differential equation. After this, I will go over examples of the second order. And if you have any questions, as always, do leave comments, and I'll be sure to get back to you as soon as I can. All right. Thank you very much. And do remember, always pass on the knowledge. All right. Bye bye for now.